Hi, how are you? Um, for some mysterious reason that I can't connect to the internet, but now we can. Um, so next Tuesday's holiday, but unfortunately our class on Monday and Wednesday, so we still have class. So now what we want to do today is to finish up the topic 2, then we go to the probability, then we go to the random variable, which is going to be an advanced topic in probability. Okay. But before we do that, very quickly, we will review what we have done, because I think the solid foundation of the probability will help us to do the foundation for the random variable, because random variable is basically the, as we will define later, is to simplify the sample space to numbers. Okay, instead of a complicated sample space, we'll consider numbers to for that purpose. Okay, so let's briefly review the idea of probability, right? So do remind yourself that what you learn in the high school is entirely classical, in the sense that you rely on the idea of random experiment, something we're able to repeat many times, then almost identical conditions, and that means that you expect the probability to be able to assess something likely to happen or not based on the ratio, right? It's the relative frequency idea, right? So that is something that we can repeat. And what we learn is based on the 3 axioms. Okay, the first one is axiom means that I have a sample space, right? And I would assign any event, okay, a number between 0 to 1, and the sample space is 1. And also, if we follow the idea that if an event consists of mutually exclusive outcomes, and probably the event will be sum of the probability of all outcome, right? The whole is sum of its all parts. As long as it satisfies this condition, okay, then we can call it probability measure, or probability, or if you like math, it's called measure. Otherwise, it's something other than probability, okay? And these 3 axioms will derive as many rules, right? Based on only these 3 axioms, right? We know there are many rules, and in the assignment, you will have time to a chance to familiarize yourself with these rules. Do you know that, I mean, we can't go to each single rule slowly, because it will be tedious and also we're boring, right? That means that you have to make yourself understood through the exercise. You apply it, then you know it. As I always have metaphor, right? Just like swimming, right? I teach you on the land. There's no way you can master. You have to swim by yourself, right? You have to do it on your own, and then you know what's going on there. In particular, this complement rule, we will be using it throughout the second half of the semester. That you will know very well is this complement rule we use all the time. And the other one, which is often useful, is the addition rule. Is the union will be sum of its part minus its intercept, or intercept will be sum of the separate part minus the union. Okay, so that would be the idea. And do remind yourself, if you can't recall, just this picture is the red circle plus the purple circle. You minus the duplicating overlapping pink area will be the area of the goggle. All right, so this would be the one that keep in your mind when you have the formula. And also with the formula total probability, right? This is just saying that the part with A will be A with B and A without B. Okay, so And this is a formula that we useful. Remember the base rule we learned on Monday. So this is the denominator, right? And after that, we have a short detour about on odd ratio, right? And with odd ratio, you would appreciate y with probability, right? But probability is 0 to 1. It's easy to see what meaning is 1, right? With odd ratio, it's 0 to infinity. So what is the odd ratio of 99999? How do you compare? It's very hard to say, right? What is odd ratio? It's 1000. It's not easy to say something, okay? But this odd ratio is useful when things are simple, right? And also odd ratio is simple when you think when you look at the casino betting, right? And you can convert the odd, right? From the bet to probability. Okay, so that is the useful application that you would think. Okay, so that's why when you learn finance, right, and you have common stock, you also have derivative. You have a future or options, right? And that's why sometimes people can say in the finance literature, you see from the option or from the you can do the implied volatility, right? I mean, if you learn that idea, right, you can basically look at the derivative, can derive certain thing back, right, to look at how the stock movement, the same idea here, right? Using the odds, we can go back to probability, but that would be the thing. And on Monday, we cover something you might have not learned in the high school, which is something new. It's continuous probability. The idea is I have two events A and B. If I tell you B has happened, or suppose B is true, what for the A, right? And the idea is actually there's nothing new, right? The only new thing is because of B is true. So what outside B is no longer relevant, right? So because you want to satisfy axiom 2 where the whole sample space is 1. So that's why you divided probability B to normalize everything to 1, right? Suppose A is equal to B, say, right? If A is same as B, this should be 1, right? Given B happen, B would happen, of course, it's 1. So you look at this statement, right? A intercept B will be same as probability B. So this is 1. So this is how you may understand this formula, right? Or if A and B are mutually exclusive, right? Then A intercept B will be probably 0, right? Then that actually fit our intuition, right? This one should be 0, right? So that is the idea. Of course, there can be proof behind it, but we can just take a definition in the elementary level. It can be proved directly, okay? But we don't want to do any proof, just, okay, this definition. And we try to understand, but don't worry if you don't, but just take a definition, right? And because of this definition, right, we can multiply both sides by probability B that give us the first line of the multiplication rule. And it swap between A and B, get a second line. Okay. And this multiplication rule, together with total probability rule, will be very helpful when we do the base theorem, the denominator. Okay. But before we do that, we have to define the independence. Okay. Why we have to learn this is because A and B, if independent, means that we can assess them separately, right? Knowing A doesn't help you to B, then it's very helpful. And that is the assumption we are going to make when we collect data. Often we are saying the first observation you observe is going to independ on the second one. That make all our calculation much easier. That is the assumption that we will assume throughout our semester. Okay. And of course, we hope to be true for this one, but very often that things are not independent. You learn something actually help you to predict the other one, right? That actually is the base rule idea, right? You learn something, then you will know whether it is going to happen, right? This is the idea base rule, right? So suppose I learned that, okay, last night a wife noticed his husband is not at home throughout the night, so he will suspect something might have happened, right? Maybe he just went to the bar and beer, right? That might be possible, right? If he come back with a smell of alcohol, right? If the husband come back in the morning with a strawberry on his face, right? Then you may suspect something happened, right? Last night, right? So that would be something related to here and there. That's the base rule, right? We learn something, right? Right. That's now how we do in the court, right? If there is a crime scene, a murder, and a guy with a knife have blood stain on all his clothes, and what you say, right? I mean, I don't know, but you will increase the probability thing, or likelihood that he is part of the thing, right? But that was the idea, right? So how we update? So this is nothing new. If you look at the numerator basically is, if you use the multiplication rule, is A intercept B, right? So basically this is just conditional probability, right? Just rewrite the numerator here, right? It's A intercept B, right? Just multiplication rule. So what is the key in this formula? There's nothing new here, right? Why we bother this? The key is we're able to swap ourselves through this formula, right? By swapping this, then we are able to change our idea, because this is what we know, right? This is our prior knowledge, okay? This two item is our understanding of the world, how A with the B, right? How A happen change our B, right? It's like how we understand the world, all right? The mechanism. This is information, right? That understands for the science or logic or whatever there, all right? So this is our updated knowledge, this posterior, okay? So just to make our life easier, then you can look at this tree diagram. I always remember through this diagram, because remember, formula is very dry and you can never remember it. Maybe you can remember it in a week, but after a few months or after years, you can't really remember. So I hope this tree diagram will stick in your head, okay? So basically, you can imagine A and AC, right? Something we don't know. This prior knowledge we assign to one of them, right? That is our current understanding. How is the world? How likely PA is? How likely that the world is under A? How likely the world is A and A complement, right? You can imagine, as I said, the stock market idea is there's a breakthrough in the technology. It's called A. A complement is actually the company haven't done the breakthrough in the technology, right? And under the case where the technology is breakthrough here, right? There will be likely that there will be upper thing is the B and B complement, right? Which associated with the stock price goes up or go down, right? And same here, right? And of course, if you notice the stock price has gone up, right? Which the B happened, you try to infer whether the world is A or A minus A complement, right? So basically, it's just like this is A is our thinking of the world, B is actually observed, right? Of course, these probabilities are different, right? If the same, you can never learn what happened in the world, right? If these things are no different, actually, we don't distinguish them anyway, right? But anyway, it can be discernible because these are probabilities are different, okay? And what we want to know is, okay, now we observe the stock price has gone up. So the only relevant part of the sample space is this branch, the third branch, and the first branch, right? So we want to calculate the probability A, right? So basically just this over sum of the two with the ratio, right? Suppose this is very big, this is very small, then we will think A is very likely, right? So this is the ratio. It's a very normal, right? Look at the proportion, right? Right? So that is the idea. Okay. So just go back to this example. I mean, I'm sorry that if you have already known how this works, we repeat because this is so important. As I said, this is one of the most important things you want to learn from this class. It's the base rule because this is, if you want to say how you distinguish high school kid who know probability, the base rule. I don't think they know very well. I mean, if they don't calculate, they don't understand the logic. So it's very important you know how to operate, and this is basically the how machine would learn or how people would learn, right? Because you want to, these days are, now we have artificial intelligence coming, right? Then how machine learn, how human learn, right? This is very important, right? Even though you hate math, right? You should be able to understand what's going on here, okay? So here the example is very simple. So the nature would decide A and B, which bed to be drawn, right? So there's something we don't observe. That's all I have to learn, okay? We don't know, okay? And we're going to, we know that, okay, if A has been drawn by the nature, there will be 5 balls. 4 is white, 1 is green. If ball B is being drawn, 1 white and 1 green. Okay, so that would be the understanding of the world, right? This is the scientific knowledge we know, okay? But we don't know actually this one will be drawn. Okay, there's assumption here, but this we're going to make, okay? So the question would be, now we've drawn the ball of white. Is it A or B? So that's a question, okay? So how do we do this, okay? So the question would be, if you phrase it in probability statement, it's asking, given it's white, how likely is A, how likely is B, right? So this is the same thing, okay? And remember the complement, so add up must be 1, right? Because given the white ball, it must be either A or B, right? Cannot be C, right? Because as I said beginning, right? There's no surprise of outcome, right? It's either A or B. It cannot be a rabbit, right? That's why you draw a ball there, right? It's cannot. And how we do that, right? How we do that is based on the base rule, but right? It's based on this rule, right? How we do about that, right? How we do that is, if I want to find A given B, you just basically swap them, the numerator, right? Change up in A, and you multiply the first item and divide it by the second item. That's how I remember, okay? If you need to remember that, but again, you have your notes, it's open book, so there's no need to remember the formula, just look at it and apply it, right? And remember the numerator is how we understand the system, right? If A bet is being drawn, there are 5 balls, 4 is white, so it's 4 over 5. And because it's close to I, okay, our understanding I is close is half, okay? And if this is white, okay, then this is the probability we calculate, right? So this is how you come up with the updated, right? If you white, that is more likely is 8 over 13, the other one is 5. Right? The odd is 8 to 5, right? So that is how you would do this calculation, right? So then you would understand, okay, that it seems more likely to be bet A, right? And then you can keep drawing the ball, and then you can see this content update. You can do the same process, but as I said, in our class, we just require to do 1 update, but you can keep updating, and then you can learn until you keep learning until things goes on, right? And that's why, right, people in relationship take a long time before they engage, and when they engage, they get married, right? Because it takes time to learn until you're sure certain threshold that your partner is a perfect match, then you go ahead, right? So that is the main idea, right? Is you keep learning, you keep doing the things, and until you update, right? Because once you did that, this thing 8 over 13 become here, right? And of course, this one will change. This will not, but this numerator and denominator will change, right? You keep learning new things, okay? And then keep updating. Let me go back to this example again, because this method example, you often see it, and then you will see the same thing in your assignment, so you can try. Or I just remind you that the assignment has been released. Okay, you have the 2 weeks to do it. Shouldn't be very difficult. Okay. So here again, I just go slowly because this is one of the most difficult part, I would say, right? At least for the first half of the semester, it's the most difficult part in terms of philosophy, in terms of application-wise, it's most useful. So consider case we have a population, 40% is infected with certain disease. We want to know what happened, okay? And what we know, we have an imperfect medical test. If it's perfect, then we're done, right? But if you ask people from the medical school, they know that they will never know that none of the medical tests is perfect. Maybe 99.999, but still there's a chance there's error. Okay. And in fact, the person have positive result of 80%. Okay. That means that if you have or you are infected, you still have 20% that you have negative, right? So that will be false negative of 20%, right? And uninfected has false result is 0.4. So that is the bad thing, right? So with a false positive of 40%, right? If you are uninfected, 60% of the time you're okay. Okay. So that is the question we have, and then that is the thing that oftentimes the medical doctor is going to face, right? So that's why you may ask why the threshold to become a medical doctor is always high. Why you need people to do a good math, because they need to calculate it in their head, although they don't do it in the paper, but they have to do it in their head. And that's explain why these days, when you look at the artificial intelligence, the medical application, actually the AI do better than human, right? Because actually what is the doctor doing? Doctor is doing is a human calculator to look at the test, apply, right, the base rule, and see whether you do other treatment, right? I mean, so far the artificial intelligence is better in terms of the general practitioner, right? In terms of prescribing drugs and things, because that is the idea, right? Because prescribing drugs is basically correlation idea and also the probability calculation, right? This, right? I mean, of course, doing surgery still not that there yet, but you know, the recent development, the surgery still machine is already better, but sooner or later, right? But anyway, now I mean, let's go back to the real world. We want to do the calculation, right? So what we have is the question. We define A is infected, B positive result, so A is 0.4, right? And given you have the disease, you are test positive is 0.8, and AC given A complement, B is 0.4, right? One is given positive result B, what's probability you are infected. Okay, so that's what the doctor do, right? You have positive result. I want to know whether you're infected. If infected, I want to give you a drug, or you want to be hospital for quarantine or whatever action to take, right? If it's high enough, then we're going to do something, right? And of course, I do one test. Is it high enough? Not enough. I do one more until we got the right thing. Okay. So how do we do that, right? Just simply apply the base rule, right? It would be a fraction with denominator is probably B. Numerator would probably be given A, just reverse it, and probably A. So that is how you do it, right? Just remember the formula, right? Just look at here. Even though without doing anything, this is the formula, we copy it first. Okay. And this first term, A given B, right? For B given A, this is something we know. The knowledge is how good the test is. It's current technology, right? Or understand it well, right? It's 0.8. Okay. And this probably A is our prior, which is something we know already, 40% of the population infected. The only difficult part is denominator. Okay. The denominator requires you to do the calculation like this, right? Whether you are having positive result or not, right? In the raw, and then you divide in two parts. You can be positive under actually you're infected, or you're not infected, right? A is infected or not infected, right? And then you can use the condition. You can use the multiplication rule to separate A and B by B given A and for A, right? You may ask, well, why I have to do that? Why I do A, B given time for B? But if you do that, you can't go anywhere. So you have to do it this way, right? And this number, you know, all the number actually you know, right? Then you just apply and plug in and then you're done, right? So at the minimal, Even if you don't fully understand this, that's okay. You just follow the procedure and do the operation, and then you're done, right? I mean, I would say don't feel too bad if you don't follow, but at the minimum, you can follow the operation. And then time and time pass, you appreciate, right? It's like swimming. You don't understand why you do that. But if you swim long enough, then you're gonna say, okay, why you have to, I'm not expert, but why you have to pull your finger together, right? If you try to not do that, then you can see the resistance is much more, right? You learn and learn, right? Why in the school, in the primary school, we have to say greeting to your teacher, stand up. I mean, not in the US, but at least in Hong Kong, that's how they're being taught as kid, right? Because you learn how to respect, right? Why in some Catholic school you have to learn to read Bible or to memorize some of the passage, because sometimes you understand, you remember, right? Just like the poem in the Tang poem, Chinese poem, you remember. Sometimes you slowly understand what's going on. So it's okay. You don't have to fully follow. Or with some of the master of comics or master of painting, at the beginning they mimic, at the end they have their own style. So it's okay, you have to mimic what is being done, and one day then you understand. Okay, you may not fully follow, but one day you understand. Okay, it's okay. That day may come or not come, doesn't really matter. You follow, you know the operation. We know how we do it, right? You don't necessarily understand every aspect of your life. Like look at your smartphone, right? You don't understand how you operate, right? How this cell phone communicate with the cell tower. You understand how it works. It's fine. You know how to operate, right? For every app, you press the button, you don't understand what's going on, but you know how to operate that. That's fine. Same idea here, right? You don't have to know every single aspect of our class, but you know how to operate this space rule, then you're done. You're fine. Okay. I'm not going to go to every single detail, but I would just very quickly go into this counting concept. This is trying to prepare you for the random variable. And also this is often taught actually in probability theory class, combinatorics. If you learn computer science, the first class in discrete math, they will teach this, okay? Because counting and is very important to understand probability. But we're not math class, but we still need them when we talk about random variable. Okay, when you talk about binomial distribution, there's easy way to understand random variable, and that's why we need it. Okay, so let's see the counting. Okay, if you learn math M2 or some advanced math, is something very simple. Okay, counting is, suppose you have a mission. Okay, you're James Bond, right? You're going to do two things, right? James Bond is going to the enemy base, okay, and then blow up the evil plan of the evil guy, right? And you can imagine he have two tasks, right? Have to get inside, right? The enemy base. There are many ways he can get in. Maybe he do something crazy, drive the airplane or submarine or whatever, right? And get there. That end one way, right? And there are many ways he can complete the task. Very often there may be a beautiful girl there, or there's a crazy guy there, bomb up the whole world. I mean, there are many ways, but the end two ways to do the second task, right? Or use the bomb to bomb up the plane or whatever, right? So then the question is how many ways the James Bond is going to finish his task, right? So then how is going to do that? And the answer is very simple. The answer is just multiply. Why? Because you can list them in a table, right? For every thing you can do for the first task, the n two way to do the second one, right? Then you have count how many times to do it. It's just you add n to n one time, so it's multiplication, right? That's the definition of multiplication, right? It's just repeatedly adding things, right? So that means that you can do generalize it to multitask mission, right? Suppose James Bond not only blow up Mr. Evil number one, he's very busy, right? He have to go and blow up minor base of base 1, base 2, base 3, base 4, right? Usually James Bond, it doesn't end blowing up one base, right? He blew up every single bases, right? And then he have K different evil guy to deal with, right? That then each task has n(i) way to do it, then will be n1 times up to nk. Good, this is the example. Okay, it's very abstract. I would prefer to give you an example that is very local. That's what I do when I was a student in CHK, right? I'm poor. I was poor, but I still poor anyway. But you don't expect a professor is very rich. Usually, the richest people in the school are students. One of the richest. You go to U.S. college or everywhere in the world, people who drive the school are students, and professors usually walk, or sometimes they drive, but they drive the old cars. But anyway, so what I do is I was a student, right? I don't have money. Then what I do is you can buy a simple meal, okay? In here is what 退飯 means that you don't have enough money, you don't have things to do. So what you do is, I think they still serve in the canteen here. I think they used to serve like $10. Now it's 14, I think, but still 10. It was $10, $9.90, not less than 10. So what you do is you choose one or two main dishes, either rice or noodle. I think noodle is spaghetti, means either rice or spaghetti. Okay, and then you can choose one of the three meats. Okay, it's pork. Actually, I think a luncheon meat, beef and chicken. Okay, one of them. And then you have choose one of three sauces: black, white, or red. Black means the pepper. White, I think, is the cream. Red is the tomato sauce. Right, one of them. Right. The thing is, you don't have money, right? I mean, I don't have money. Maybe you have, but anyway, I don't have at the time. So how do you think? It's like you can't have the same meal every day. I mean, right? You're crazy, right? But so how do you do that? It's just like you rotate, right? The first question is how many times you can rotate, right? So you ask how many different kind of combination you can have, right? So it's very simple. You have mission of 3 tasks. Mission 1 is to choose the main dishes, 2 of them, right? And then one of the 3 meals, 3 meats, then it's 3 of them. Sauce, 3 of them. So it's 2 times 3 times 3, right? Which is 16. So that means that if you go to school 4 days a week or 3 days a week, usually 3 days a week, right? How you pack the class. So every 6 weeks, you can rotate without difference, right? And you only have 12 weeks usually, right? So you only repeat yourself 2 times in a semester, which is okay. I can survive. I survived by this. So luckily I'm okay. I mean, hopefully you don't follow my route. I mean, I just did this, okay? But hopefully I think you have a much more abundant choice of food. By that time I save money, so this would happen, okay? And I think other canteen don't serve this cheap meal anymore. I think used to be, I was in New Asia College, so New Asia College also have that. I think it's not $10. I think $10 is $10 there. And the canteen, the Franklin is also 10. The cheapest is in the CC canteen is $9.50 and $9, so it's cheaper. They also have the egg. The egg version is cheapest. The vegetable is cheapest. If you don't need the meat, they have a choice of eating veggie. It's $9. At that time, it's like 10 years ago. Now it's like, of course, $14 or $15. But still, I mean, you can see still can survive with little money. So let's see how the counting works, because counting is actually useful, as you will see. But if you learn public class instead, department, they will keep asking the same question. So like this question. So if you roll a die twice, okay, and you want to not care about each row, but sum of the numbers, and you say what's probably sum of the face values is less than 12, okay, right? When you roll the die twice, what are the possible outcome is 2, right? 1 plus 1, right? 2, 3, 4, 5 up to 12, right? But remember, not all the outcome equal likely. So you cannot simply use, say, 10 over 11, right? Because there's 11 outcome out of 10, right? Less than 12. So you cannot use that. You have to do counting, right? You have to count how many possible outcome here first, right? Because you roll the first die, you have 6 outcome. Second die, 6 outcome. So total false outcome is 36, all right? And if you want to think about the event that is less than 12, that is complicated. But if you think about a complement, less than 12, that means only 12, right? Because no more than 12, right? So 12 is the one that is complement. And how we get 12? Only possible is 6 and 6. So it's 1 over 36. That is probability of a complement. And apply complement rule is 35 over 36. Then you're done. So that life is much easier when you know how to do counting, right? Because each outcome is very likely, right? When you think in 36 outcome. When you think about the outcome is 11th time, 11th outcome, then it's very difficult to do calculation. So that is why counting is important. Okay. And we will introduce 2 more counting thing. It's called permutation. Okay. This permutation is very simple. It's what you do in the primary school and kindergarten. Line up. Okay. Or what people in Hong Kong said one of the people that like to queue up, right? Or maybe Japanese is one of the best, but we are maybe second best or third best, whatever. One of the top, right? How to queue up. So you try to line up things in a linear order. Okay. So you have say n objects. You want to put them on the line. How many different ways to put it? Okay. Put a line means the first guy and the second guy they swap, they're different thing. Okay? Because the order you agree, right? So how do you calculate that? Actually, it's coming from the counting principle. It's multiplication, right? Suppose you have 10 students. You want 10 primary school students, you want them to form a line, okay? The first guy can be any 10 of them, right? But once you put the first guy there, you only have 9 people there, then 9 there, and 8, 7, 6, 4, 5, 3, 2, 1, right? So that means that you 10 multiply up to 1, okay? And in math notation, if you start from the first one, multiply to the last one is factorial, okay? This is called factorial, and this n factorial is like this. So that case is 10 factorial, okay? Now we can even generalize this to more general cases. You don't have to use up all 10 people, right? You have 10 students, you only need 4 of them, right? Then it's 10 multiplied by 9 and 8 and 7, okay? So that means that 10, 9, 8, 7, not 6, okay? So n minus r plus 1 because you minus 0 here. You're counting from 0. So that means that this notation can be write n factorial over n minus r factorial because you can go back and then add them. So that's refer to NPR in your calculator. Okay, all the calculator have that. It's called permutation NPR. Okay, so this is we do it. Okay, so you will ask why we do it. Application. Okay, and this also actually come from an actual example when I was in Singapore. Okay, here I don't think the subway, not the MRT, not the subway. Subway is the sandwich subway. Subway is not very common, right? But I think in Singapore, I mean, it's everywhere. I mean, much more common than here. Subway is the place to sell sandwich. Okay, and why I have that? Because we have a research meeting among students and faculty, and then what we do is we have a free lunch, and I was responsible for ordering Subway's sandwich because that is within budget because we don't have a lot of budget. It's just like I think we have $8 per person, $8 Singapore dollar, like $15 per person. Okay, so I don't need to eat $10 a meal. But anyway, so the idea is like the Subway sandwich will be like they have choose bread, but you can there are more choice. But I just make to be simple. I just 3 different type of bread, and they have 2 out of 6 ingredients. You can put 2 there. Okay, and you know the Subway, right? They would put ingredient 1 on 1, right? So that means that if you put veggie at the bottom and beef on the top is different from the other way around, right? Some people are picky, right? Because vegetable there, the beef is here. They were saying the beef, the juice will go down. It's different, right? If you put the veggie there, there's some water will fall down on the beef, they're different. Or especially when you have egg mayo or tuna, that thing it will be different, right? I mean, people will say you're picky, you're different. Okay, you have to specify, you have to tell them in the note, you have to put the tuna first and then put the veggie on the top. I mean, you have to write down in the remark there. But anyway, that is the thing. So the question is, given this example, how many types of thing you can do? Okay. The first is very simple. You have two missions. Mission one is cook the bread. Mission two is put the ingredient. Okay. The bread is three choices. So no matter how you choose this, you have three ways to do it. So three. Okay. And the ingredient, okay, you have to do two of the ingredient. Okay, you have to pick two. You have to pick two. And order matter. So you have veggie first and beef on the top. It's different from the other way around. So you are choosing two ingredients out of three, so go 6 on the line, right? Put them on the line, right? So that means it's 6P2, okay? And calculator will tell you 6 times 5, right? Because the first one, there's 6 choice, the other one's 5. So actually you have 90 different choices, okay? So the good thing is in this sandwich case, probably you cannot run out of option that easily, right? Of course, it turned out very interestingly, people keep ordering the same thing all the time. I mean, even the sandwich is different from the case of the rice is people keep changing, but this one is people actually keep almost always they keep the same thing. I mean, if they like egg mayo and tuna, they always do the same, and they always have the same order they have to order. But anyway, that would be the thing I have. Okay, I hope that you find interesting because these are all motivated from real world. So the next one is same as permutation. You're asking people to come to form a line, but actually I don't care the order. Just pick up someone to do something, right? Just imagine our class of 70 students, all right? And suppose we pick up 5 maybe person to participate in a competition, right? It doesn't matter who drawn first, who draws second, right? And that means that how many different way I take n ball, r ball of n, right? It doesn't matter who's going to be there, all right? In that case, what you do is, because NPR is n different way to pick our guy, right? That means that you swap them, you pick our guy, swap them, the R factorial way, right? So you divide them means that you remove the duplication, right? Because for every R guy you have, the R factorial way to reorder them, right? Because R of R. So that's why you divide them is called NCR. Okay, so that would be the combination. Okay. So this is the this is the CC canteen. I think this is the Chongqing canteen because they have sausage, spam, ham, and egg. Okay, this is actually I think that one is Franklin, the old Franklin canteen, because I think they have less one sauce. They don't have red sauce. They have the black and white and rice and noodle and this 4 different choice. Okay, so you have 4. Now you have 4 different options here. 2 main dishes, 2 of the meat, and 1 of the sauce. Okay, so the first thing you can choose 2. Okay, the sauce also 2 choices, but they put your meat on the dish. I don't think you care the sausage on the left or ham on the right, or you swap. I don't think usually people don't care, right? Because you can rotate somehow, right? But if you don't care about where you put the sausage, put the ham or egg, then it's for C2. If you care about which direction they put in, then it's more complicated. But actually, I assume they don't. It's NC2, right? So for C2, so that would be 24. Okay, so that would be the way that being done. Okay, so that's different way your meal is being counted. Okay. So let's give you the, I think we have one, the final one. Okay, another example, because this would be the thing that appear in your assignment as well. So you can try to work out. I think the assignment I have 5 times or what, anyway. So you have toes and con 4 times. Okay, and what's probably exactly 2 tails. Okay, actually, if you learn ahead, this is binomial distribution. We will learn the week after, but let's assume we don't know if you know it. But okay, so you call toes and con. Each toes you have 2 choice, head or tail, right? And because we told it 4 times, so it's 2 times 2 times 2 times 2, 2 raised to the power 4, right? So it's 16, right? So the question is, okay, so how can we calculate exactly 2 is tail, right? How can we think that is the right way? Okay, so you have to think a little bit tricky. Okay, instead of con, you think of actually we have 4 balls. Each ball has a number there. Ball number 1, ball number 2, ball number 3, ball number 4. Okay, and we are going to draw 2 balls from there. Why? Because if I draw 1 and 2, I'll draw 2 balls of the 4 ball there. If the one ball is 1, one ball is 2, means that I have tail. I have 2 tails in the 1 and 2. The other are head. If I have drawn 1 and 3, represent that I have first is tail, second one is head, third one is tail, fourth one is head, right? So there's how many different ways you can have tail, right? By thinking that instead of actually toes and con, actually drawing balls, 4 balls, okay? How many different ways of drawing 2 balls out of this 4? So that means that is 4C2, okay? Okay. And when you're 4C2 over 16, that is 6 over 16. Okay. So of course, if you don't like it, you can draw a tree diagram, right? If you really hate doing this kind of math, which no one can stop you to say, first draw is head or tail, and then head or tail, and then head or tail, and then so on and so forth, right? You have 16 outcome, and then you just count. You can do that, I mean, but you can do 4 balls, you can do 5 balls, you can do 100 balls, you can't. At the end, you have to learn this, right? Because you can imagine, right, drawing a tail, right, just like drawing 1 ball there, right? How likely that you can just count how many of them, okay? So don't worry if you don't follow this as standard binomial thing if you learn later, okay? But let me repeat the argument because I want to try to make you sure you learn. I'm sorry I overrun a bit, but we're finishing this chapter, so it's okay. So the idea is we're counting how many ways to have 2 tails, okay? You can have first one is the tail or last one is tail. You can have first one and second one, so on and so forth, right? How many different ways? But you can eat the same, you consider another scenario. You have 4 different balls. Each ball have a number, ball number 1, ball number 2, ball number 3, ball number 4, right? Actually, trying to say, I actually draw 2 balls out of it. If I draw ball number 1, number 3, that means the outcome is tail, head, tail, head. If I draw number 1 and 4, it represents the number is tail, head, head, tail. Okay? Then drawing the ball is same as counting how many. Once you draw the mirror image 1 to 1, then that counting is same as this one. So that is you have to imagine your head, right? To think about that. Let me write a little bit more because I think that's important. So if you have head, head, tail, tail, that means that you are drawing the ball 3 and 4, right? If you have tail, tail, head, head. That means you have drawn the ball number 1, number 2. If you have tail, head, then you draw 1 and 3, right? So basically, no matter which outcome you think, actually drawing 2 balls out of 4 balls available, right? So that means that you can map these 2 operations the same, right? So the difficult part is to think why tossing a coin and drawing a ball. That is a kind of the head you have to twist your mind to do it. Okay, of course, not easy to twist your head, but you convince yourself you can't sleep tonight. If you can't, then try to think about this problem, then you can sleep easily. Okay, it's not easy to fully follow why is the truth. I mean, it took me quite a while to absorb it. Okay, as I said, like swimming, you have to struggle a bit before you know how to do it. Okay, I mean, I think most of people would drink some water or swimming pool before actually you can swim. Same for the math. Okay, you will struggle, stumble upon it before you can do it. Okay, and I think I overrun a little bit, so let's have a break. Okay, of 10 minutes. In the meantime, we will we'll do a you reply. Okay, let's have a break of 10 minutes. You are encouraged to fill in the form so that I know how fast or slow I'm doing. Okay.
Because you only choose to go on and then because you don't really care about all that, so you have to say for every 2 things you can draw this and this and this and this. Everything you can draw. Anyway, you can calculation you can use Excel. So that's why I'll do that.
做呢個神神呢個
呢個前貴
呢個只係
應該先重係啊嗰個，
就
因為你重係
佢我知道係成一段時
因為 tutorial 我除得嘅你咁就係課程超嘅寫。
share this share this
係我想問你以前係幾少人？
我哋就慢咗咧，俾咗幾多？schedule 你係咯，我哋目標係咁樣，就搞晒嘅應該冇難度，就搞晒，應該冇可能搞晒。我哋買咗幾多啊？
我哋
你應該好快，好快。搞晒搞到要。
咁就
咁慢慢嚟，唔使急。
有得學識咯，我搞得快冇用㗎。
唔使急，最緊要快，
最緊要
最緊要慢。
將慢。開心搞錯
你話佢咩出事就即係話，因為對方發生啦，咁應該咩都話佢哋快嘅。
啊？
我邊個揾住手？
咪最細嗰個咯，搞錯啊！
就唔係嘅。我哋出去就唔係嘅，我哋又唔係嘅。
我真係
隨便一件事發生，
得一堂。
搞上
到學啦，
係啦，咁我哋咁樣解釋佢啦。咁我哋嗰樣嘢因為呢個條件嘅時候，你錢我都個拍嘅，咁我等你到時候我哋話我哋嗰個要講呢個係放加法咯，啲加法放加法嘅，即係話我哋就識計一個喎，我哋要以前個放低嘅，咁係會。如果唔放加法，係我哋放加法，唔放加法嘅。
嗰個係我做緊工人嘅時候，個係。
你就揾下，即係幾時先贏多少？
成個月都見。
我哋 send 唔 care 上下。更計個次序咯，快咗，所以佢哋以為就快 out 同可以上個方法。我有去 send 邊個買上嚟？喺後邊個 send， 好難。就清楚嘅，不過正常。
如果佢 send 出嚟，
考呢啲嘅，呢啲數學嚟㗎嘛。公主都唔記得，我冇所謂先嘅。我哋問你邊個得喎？冇分析到啊！你點寫咧？你寫啱答係咪？
做乜嘢？你個拖人。
或者有一食到拗嘅， So I was trying to add them up. All the four combinations with 1, 2, 3, 4, so they should all sound like still. Okay, yeah, that's not the mission. Because I like why I know like any of the 0 power is 1, but like I don't make sense for a company because they are 0 and 1. They feel like
convenient way to for formula.
oh I see.
Every formula works with combination some other formula has to sign rule.
Oh, yeah,
That's what
oh yeah, yeah, yeah. That's good.
没有放这个。
Basically, it's like yes.
And then it's one way to just
Yes.
miracle.
我最難。
So that's why.
No problem. Although it makes any sense, but it works conveniently for everyone.
跟住之後，
What was the amazing version of the numbers? I mean, that is the most amazing equation that ever invented in formula.
But how's that? Because one is
Was that like
you can't tell.
Yeah, I can do that out. M.Phil. Compact number. I is negative. Just advertise it.
開心啊！努力有係
Don't do it.
Yes.
So let's see how the base rule. Well, the base rule is simply, if you want to put it simply, just definition of condition of probability, and then with multiplication rule, and that's it, right? But do remember that multiplication rule It also comes from definition of condensed probability. So basically definition. You will say, if you really want to say that nothing less than is a definition, right? But by itself is consistent, it works out miraculously. Very nice. And the main idea again is this. Just, I think it's good to, we call this red thing, right? Is the world, the nature, or the God, whatever you say, decide the world is A or A complement, right? The company actually do breakthrough in the technology or not. We don't know. The company people know, but as an outsider, I don't know. Okay, you have assessed the probability, right? Or the guy have committed a crime or doesn't. Okay, you have some knowledge. You bring some evidence, B or B complement. Okay, and then if you evidence B, the only relevant part in this tree are all the red branches. Okay, either the first branch or the third branch. You ask us to evaluate how likely the world is in A rather than A complement. So that's very simple. That's a ratio, right? It's just the number you got the first branch over the sum of the first and the third. That's it, the ratio. That's the base rule. Nothing new there, right? Because only relevant is the red one. And you tell me that you want to assess whether it's on the first rather than the third one, right? The first one is A happen. The third one is A complement happen. So we just, the first over the sum of the two branch, right? That's base rule. Nothing new. But of course, as I said, if you don't understand, you just don't understand. It's very difficult to say, to make sure you understand. It's just like, you can work it out the problem, then you know. I mean, it's very hard. I would say if you don't understand, you don't understand. You understand it. Oh, sorry for that. So how could we do complex experiment with different subgroup and within group? Okay. Okay. So line up a class choosing 5 guys and 5 girls where order matter. Okay. So that would be involving, you have, suppose I interpret the question is like you have 10 people, you have out of 70 people, say, you have to draw 10 guys, 10 people, 5 of them are boy and 5 out of them are girl, right? Order matter, right? Then what you're going to do, right? This is not the binomial, it's like multinomial, right? So how to do that is a little bit more complicated, okay? How to do that is you have, imagine that you have 10 different, maybe make it simple, okay? To be too easy, put a much more simple question because you can generalize it easily, okay? Make ourselves, suppose you have, make it simple, we have 10 person, okay? And you want to draw, say, 2 boys and 2 girls, okay? And then you get different order, okay? So how can we do it for the first object, the first slot? How to do that? First slot can be, okay, can be boy or girl, right? And the boy or girl, boy or girl, boy or girl, right? Then, of course, the easiest way you can list them out, right? But is there any smart way to do it? Right? Is there any smart way to figure that out? Okay. And suppose you have to think the following. So the easiest thing is to divide them into 2 tasks. First, if to choose boy out of 100 boys you have, 2 out of, say, 5, and girl 2 out of 5. How many are going to do it? 5C2 and 5C2, right? And multiply together. Then you have 4 boys and 4 girls. So 2 boys, 2 girls. And then choose them, you can reorder them, it's 4 factorial. So it's 5C2 over 4 factorial. Yeah. Then in this case, I don't know how many, maybe you can just adapt the number to that what I said, right? Suppose you have, I don't know, 10 boys and 10 girls, right? That would be 10C5, okay, 10C5, and then 10 times 10C5, and then 10 factorial, right? Because you choose boys, choose girls, don't remember, order doesn't matter, right? And then you rearrange them. That's how you think. Of course, there are more than one way to do it. This problem, this is I think about it this way, but you can many ways to do it. As I said, our class don't want is a math class, is not math class. I will not ask this question like this. This is you expect in the math class. Okay, I just introduce that because you want to understand the logic. If you don't get it, it's okay. Okay, so don't worry about that part. Let's go. Oh, so far so good. What to eat for lunch? Oh, there are many choices. I told you already, right? You have doing combination. If you go to the canteen, 18 choices. If you go to this one, you have 90. So a lot of choices. I hope you can do combinatorics when you go to the canteen. Yeah. Oh, just remind you today's Wednesday. Don't make mistake. Yes, swimming on the land doesn't help. I mean, you have to actually go to the water. Yes, different group there. That's right. The order matter. Answer M.Phil. Well, you have 2 weeks to do it. I think, to be honest, if you understand the material, it should be less than an hour. You should be able to finish everything. I think we only have 5 assignments for our class, and final project and the test. So only 7 tasks, right? So shouldn't be that difficult. Yeah. One person complaining, can't follow. The speed is okay. And some of you asked me during the break, we are following by the schedule, which I do not worry too much because we want to cover the material so that deep enough so they understand, rather than skim through so many stuff, right? We can be a little bit faster at the end because the end thing is more like procedural stuff rather than we don't do proof. So there's nothing to understand, but there's some procedure. There's some intuition. So that's why with the solid foundation at the beginning, that is more important.
會覺得呢個係零嚟㗎。
Oh, too many links. Today we are one of time. We don't have time to go to single of them, but let's pick up one of. We have many links here.
係三條啫，驚啦。
Let's try.
睇少少。
3條唔驚。
So someone said I should watch all of them, but let's see. Let's see. The first one is okay. Let's watch. Do you have nothing to share?
為咗認真對待今次嘅實驗，我哋睇晒150畫切卡哇動畫，就睇下烏沙基叫咗幾多次。開始第一集，好似有150集。睇一下。
Oh, so it's basically just counting how many times he screamed out of 115 episodes. So they are doing combinatorics. So I think that's the reason why he want to share. So if you really want to count, then it's a combination problem. Okay, I'm not going to watch everything because sorry, enough time. If you want, you can go home and watch it. I hope that's okay. I'm sorry we don't have time to watch everything. Oh, this one we can watch just 1 minute. Okay, what's this? For those who don't understand, Cantonese is that you understand one, you understand all. When you understand math, rather than just calculation, then you understand the logic behind, then everything becomes very simple and life is very nice, very good. It's for the kindergarten or primary school kid to make sure that you do the dry math, you're still very happy. So I think that is what people want to say. Of course, hopefully you will not feel so bad. For this one is what?
To you, happy birthday to you, happy birthday.
Happy birthday. Okay. So I don't know what does that mean, but is this fun? I don't know. It's fun. Forgot to use my calculator. And do note that with the permutation and combination, we don't need calculator. Actually, you can use the Excel, permute and combine, and you get calculation. Okay, and so that would be the formula. I'm not going to show you. I think it's easy to do it. Okay, but just take up time, so we just leave it here. And the final remark would be why we care about this in statistics, because principle of counting, you just keep multiplying. It's similar to actually what we would do when we do random sample. Each observation is independent. And when you do order the sampling without replacement, there is permutation. And then when you do sampling without replacement, then it's combination. I mean, it's still, this one is like a little bit tricky to you, but later, if you ever go to the case when you do sampling, then this will be do the calculation there. But I don't want to talk too much on this. Okay, but I hope, as I said, when you go home, especially you have a holiday, right? You can try to do this. You have more than 2 weeks to do it, right? It's at the midnight of 10. Then just first question is very simple, right? Just calculate the thing we learned in chapter 1, right? All the sum of statistics, variance, correlation, and then question 3 just Excel formula, which I think you know very well. And then here, toast-con 4 times, actually, we have done already. And then some probability rule, actually, you would just apply. And then there's some Bayes theorem that actually you would want to apply as well. And then some counting rule. Okay, so if you understand, you should take no more than an hour. If you take a little bit struggle, maybe 2 hours at most. If you more than 2 hours, I recommend you still struggle. I recommend you talk to your TA. He will try to help you to do the assignment, or your friend. Okay, of course, TA will not tell you the answer. Okay, don't expect the TA say, is it right? The TA not telling you, but if you have some question, they will try to teach you some alternative way to make sure that you try to know how to do the assignment. So do contact TA if you, or email TA if you don't, you are confused. But don't email TA to check your answer is correct or not. Okay, that is not going to be accepted. They cannot answer it in this way. Okay? You can clarify the question, but not, or try to help you understand the material in the lecture note, because it's very similar, right? So if you see this, everything is very similar to the example we gave in the slide. So unless if you don't get it, look at the green slides we have, then you should be able to do it. Okay. And so as I said, I think the assignment is loosely graded, in the sense that if you attempt, you get a lot of credit already. So just make an attempt to, I think, do what, right? What I do is, right, if you have serious attempt, you got 80% of grade, right? So if you, the 20% remaining will be your accuracy. So if we figure out that the TA think that you have seriously done it, you get 80 marks, right? If you If you submit something rubbish, of course you get 0. But if you submit your accounting assignment to our class, it's not going to get any credit for it. Okay, don't write anything rubbish. Okay, at least write something relevant to the question, right? And then you get 80 points, and then the rest will be based on you get 80 points, 90 or 100 or 85, 95. But more or less, just try to do it. Okay, if you fail assembly, it's not end of the world. It's not. You will still get most of the credit. Okay, and you're welcome to talk to your friend. It's okay, but submit your own version. So topic 3, you can see we have 200 slides. Some of you also worry about whether we can finish it, but don't worry. We'll finish it because many of them are graphics, many of them are Excel formula, so it's not that crazy. Okay. And random variable. Okay. So random variable is a misnomer because it's not a variable. Okay, it's a function. Okay, the definition. It's a function that basically maps outcomes to number. Okay. Remember random experiment with many outcomes, right? We toss a coin, outcome is head or tail. That's not a number, right? But we can assign number to it. Okay. You may ask why we do that. Why we care about number? That's crazy, right? Why head is equal to number, say 10, tail I put number -1. Why to put number there, right? Why I don't want to just study the sample space by itself? Why I have to map the sample space to number? The reason is being that we know how to handle number. Okay, with number we can calculate mean, variance, those kind of stuff, and we often actually care about number rather than the outcome, right? So suppose the concept posing a coin, we may care how many heads we have or how many tails we have. Then it's number, right? And in the financial or business world, we care about numbers often. So we don't study probability by itself. We do sometimes, right? But sometimes we consider a more simplified case. We call it random variable, where each outcome of the random experiment, we put a number there. Of course, the number you put in the outcome have to be meaningful if you don't want to have the meaningful conclusion. But random variable, we just put number. And by putting number, we can have something more meaningful thing to say. Okay. And that's the reason why we do it. Okay. And traditionally, what kind of number can put in is called a support. Okay. I mean, it's the range of the functions, right? If you want to say what number you can put in. Okay. If what you can put in is usually now is the sample space, right? The new sample space, right? Rather than say it's head, tail, head, tail, head, tail. I tell you that is how many number of tails, how many heads, right? And classically, they would distinguish the study of random variable in 2 parts. One is discrete, one is continuous. Okay. The reason that discrete means that finite numbers or countable, if you want to be terminology countable number of outcome, you put integer, say, then you can count them. But continuous means that you will use decimal numbers. Why the case? What distinguish two? Discrete, you can count, so you can use standard math you learn in the high school. Summation notation, that's fine. Continuous require calculus. Okay. Since our class don't require calculus, so all the calculation you learn in the discrete first, And everything you learn the calculus, we will just saying that integration, differentiation in the high in the background. Okay, but don't worry about integration and differentiation. If you learn calculus, what we need, integration is finding area. Calculus is just the slope. That is the thing we need. Okay, but we will be more clear later. But of course, the reason you will ask is why we learn to learn this kind of stuff. Why we do learn random variable at all? Because in the real world, a lot of things actually follow. If you try to measure things, that will the probability, the structure follow some simple mathematical structures. Okay, what I meant is with a sample space, with some random variable with some probability, right? And the probability can be anything as long as they satisfy the three axiom we have, right? But still, we don't know the probability of each outcome, right? You have to define everything carefully. But the thing is, if you look at the world, okay, turn out to be there's some structure or probability. Okay, you follow some shape. Actually, you know the bell shape thing. The bell is normal, right? And there are a lot of things actually follow this bell shape or some other different shape or skew the bell shape, right? Then things become more easy, right? Then you learn how to describe the world, a lot of approximation, right? That's imagine how you learn the arts class in the primary school, right? You learn how to draw people, right? Then how you learn is, of course, you can, each people is very different. Then you have to learn how to draw each one is very difficult. But you learn how to draw stick figures, right? How the circle is the head, right? A dog is the hand, and a stick is the hand, so on and so forth. You learn the basic skeleton there. And then if the skeleton is rich enough, then it's done, right? You don't have to draw every single detail there. So that's the idea, right? Because a lot of random events can be easily approximated by a well-known probability model. Okay, so that's why when we learn this is a lot of business environment, business process we learn actually follow some nice property. Okay, we learn those models, then we know how to model them. Say, for example, when we learn later, you see when we try to model the arrival of customer, actually later we see we follow a Poisson distribution. If we try to learn what is the IQ in a society of types that follow the bell curve. Okay, when we try to learn how many coins total number of coins, how many head or tail is a binomial. Or engineering, you have in an airplane, you have 8 engine or 6 or 4, right? How likely the engine fails, right? That is followed binomial. Okay, many of them actually follow these things very nicely in engineering or business. So that's why we learn them. So even this by itself is already very useful because as you go to audit, okay, you find how many defective items there is also a what we call hypergeometric, right? Say suppose your client told you that 10 machine in the or maybe hundreds objects in the warehouse. Okay, all of that, 10 of them are defective or bad item, 9 of them are good. Okay, and then you want to check the claim. Then how we do sampling, right? You are going to draw randomly, close your eye to draw, say, 5 objects there, right? Then suppose you have figured out that 2 of them are defective. How likely that you want to infer whether the guy is telling the truth or not, right? Is it more likely that 2 of them is bad if 10 out of 100 is bad when you draw 10 of them, right? Actually, this follows hypergeometric. Okay, and there are many things actually in the practice you can do actually follow this kind of procedure, the sampling. So that's why we learned that. So when we say discrete, I said it's a finite support integer. Okay? And let's do example there. Okay.
I took a coin, which I guess there's one of battery here. I
So how likely battery runs out? I think this is the only first time I have in the out of the 4 years during the class. So you have sample space is head or tail. Okay. Then we want to make a number. So you can make it like number of head. Okay. Then the random variable is map. Is remember it's function. It's a mapping. Tell us how outcome head tail change the number. Function is mean the way you connect them, right? So you say when I head, I'll call this 1. I have tail, I call it 0. Okay, so this I put a number 1 to head, I put number 0 to tail. Okay, that's easy. Okay, that's like this. That this function is like how each dot corresponds to each number. This is called random variable. Okay. The example we have now is suppose we do it twice. I toss a coin, right? Then I have 4 outcomes: head, 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 tail, tail, head, tail, tail, right? Then I just only count the total number of heads. Okay. Then I have head, head is 0, head, tail, or tail is 1, tail, head, head is 2. Why I do that? Because now instead of 4 possible outcomes, I only have 3. Okay. Then why I do that? Because imagine if you toss the coin 10 times, how many outcomes you have? It's 2 to the power 10. It's almost 1,000 and or 1,024 to be exact, right? 2 to the power 10. Then it's very difficult to write it, right? Equally likely each one. But if you just count how many heads you have, it's only 0 up to 10, only 11. Instead of 1,000, you have 11. Okay. Of course, what is the cost of doing this? 1, if you combine some outcome, you lose the distinction between 2. If you care about the order, you can't do it. If you don't care, you can do this reduction. Second is before each outcome is equally likely, you can just count the number, then you're done, right? But now it's not, each number is not equally likely, right? If it's fair coin, probability x equal to 0 is 1/4. Probability x equal to 1 is 1/2. Probability x equal to 2 equal to 1/4. Right? It's 1/4, 1/2, 1/4. So it's no longer evenly distributed, right? So that means that we have to study how is the probability of each number arises. Okay, so that will be something we have to care. Okay? So that is what the random variable means is HH is 2, H tail and tail H is 1, tail tail is 0. So that is one mapping. Let's remind you what we're doing is we are reducing the sample space. Because the world is so complicated, we can't do it. Imagine we are looking at the stock market. How many stocks we have? In Hong Kong, we have 1,000. In US, we have 4,000, 5,000. So how can we know the stock market? Usually, we look at the index. In Hong Kong, Hang Seng Index. In US, maybe S&P 500 or the NASDAQ, right? NASDAQ 100, right? So those are the things that we are trying to make our life easier, right? Instead of focusing on the whole world, it's very complicated. We focus on some number we can measure and single number. Okay, in our class, we focus on single number. And if you learn advanced classes, they can look at more than one number. Okay, in technical terms, we are looking at unidimensional probability, right? And multidimensional will be something that beyond our class. Okay, you learned it in finance because you talk about multiple stock combined together. We'll touch it a little bit, but we'll just leave the difficulties stuff in the later. Okay. So as I said, this assignment, right? So finally, we talk about continuous. Continuous is also very common when there are many possible outcomes as possible, right? Like temperature, right? Is any number is possible, right? And stock price is also a lot of possible. Of course, you may ask, okay, if you learn philosophy or physics, you learn the world is not continuous. At least we know now it's quantum mechanics is everything is quantum, right? But it's a good approximation already. So although the world is not really a quantum, right? But it's a continuous. Of course, some people, if you believe string theory, everything is continuous in some sense. But anyway, we forget about that. You can see it's approximation. It works nicely. That is what we do. Okay. Say the sample space for temperature is from absolute zero, is negative 273 degrees Celsius, right? Up to any number you can go, right? So usually with notation, this is a set of real number. This is set of non-negative number, okay? And another example is the stock market, right? The stock index can only go into zero, right? No negative, right? No one pay you to buy the stock, so it can be zero, right? So that is the idea. So as I said, why you would distinguish the two? Because discrete is you can count, you can use adding, okay? Summation sign, okay? But when continuous require differentiation integration, okay? But for class, we will use the notation, but I will tell you what does that mean in simple language. We don't need the calculus, but as long as you see integration, it's covering area. And differentiation is function slope. Okay, and later you will see how we apply that. Actually, we use it all the time. Integration is covering area, right? If you look at the history of math, integration comes from looking at area. It has been done in the Greek times, right? Method exhaustion. You just divide. You want the area of circle, right? You divide them into many small triangle and add them together. It's integration, right? But if the square is triangle is so small, then you add so many of them. Integration. And differentiation is invented or discovered by Isaac Newton or Leibniz, if you like, but whatever. It's looking at the slope, right? Just a reverse process of integration, right? So basically just reverse operation. Okay? So, but I'll stop here. Next week, we'll go to talk about some special cases of random variable we know how to operate. Say binomial, Poisson, hypergeometric. And then continuous, we have exponential and normal. Okay? And that's it. And then we'll see you next week. Enjoy the weekend. Remember the homework.